that there are two kinds of current. So up until this point, we've always been talking about direct current because we've been talking about batteries. Here's the battery symbol, and we would show, for instance, conventional current would go around the circuit this direction. So current always flows one particular way. If we have a short enough amount of time, that current, the graph would be real boring. It would just flow constantly. It would not change. Of course, the battery is gonna, wear out over time. But overall, if you pick a short enough amount of time, the current doesn't change. But that is not how your outlet works at home. You have what's called alternating current at home, and so the current actually changes direction. So what's really happening inside the wires at your house right now are that the electrons are just wiggling back and forth. So, inside your wire, the electrons actually don't get to go very far. They just jiggle back and forth in there because the current is going one direction and then another direction and then another direction, okay? So there's a complicated reason why that is. The main idea is that it's just better for transmission. But in the United States, the current changes direction 60 times a second. And I'll give you if you want to goof around with that, there's a way you can tell that 60 times per second by filming lights with your phone. You might have noticed it already in videos. Okay, and then, so that's alternating current is what you get from outlets. Anything that runs on electricity from a building, not from a battery. Then for safety devices, the first thing I want to talk about is like what could go wrong, basically. So one thing that can go wrong is when a short circuit occurs, and that's like kind of like a shortcut. So somehow in the circuit, instead of going through a resistor, there's a easier way for current to get around. So here, the better way would be for current to go around the circuit and through the resistor, okay? But instead, what can happen is they take a shortcut and skip the resistor and go through this short circuit. This is just a wire. So when that happens, high current means you got a lot of kinetic energy, which means a lot of thermal energy. Because whenever you get kinetic energy, you get friction, right? Even inside a wire. So that's bad news. You can get a fire in this case. So we really don't want that happening, of course, inside the walls of your house. And so what people came up with to solve that problem are a couple different solutions. So the very first thing people came up with is called a fuse. This is a blown up version of them. Most of them aren't that big. Most of them are the size of your fingernail. Maybe my fingernails, which are small and cut short. So what happens is that if you put a fuse in part of the circuit, so like this is the fuse symbol right here, then whenever things start to get warm, this will be the first thing that melts. So that way, if it melts, then this part will open. Okay, so that'll go away, and then current will just stop because just like when you did the gizmo and you took a series of resistor out, because it's placed in a good spot here where everything else will turn off, okay, then that will stop, and it'll keep your air conditioner or your garage lights or whatever from being damaged by high current. So that was everybody's first solution. Now the problem is this metal inside here is protected by glass, so it doesn't start a fire when it melts, but it's a one-time use. So then you have to go to the hardware store and buy another one, which is kind of a pain. Now, there are things that still have fuses in them. So the Christmas lights, I actually have some on the floor over here. I could snap some out, but your Christmas lights come with fuses. Your car, like your car still has fuses built into it. So it's not like they're not used anymore, but they're more used in appliances. But at your house, people got sick of these things burning out, and so they came up with a different solution, which is a circuit breaker. Because this lets you just reset it. You don't have to go to the hardware store whenever this blows a fuse. So people still say, oh, we blew a fuse, and you go down the basement and flip the breaker. But that's not really what happened. Really what happened was on the inside, so all you can see at your house in your basement is this little switch. Okay, so it flips and you got to go flip it back. But what's happening on the inside, okay, is this bimetallic strip here. When it gets hot, it bends and it pulls that whole switch thing open. And that way, again, once things get too hot, then the circuit opens and it protects your expensive equipment. I mean, maybe it's just your toaster, but if it's your laptop, you really don't want to ruin that. So, and then by the time you can get down to the basement, things have cooled off, okay? And you can flip it back and everything will be fine again. And then you don't have to go to the hardware store and buy a whole new fuse. And sometimes you just learn, okay, fine, we can't have the hairdryer and the vacuum cleaner running at the same time. Okay. And then finally, for a different thing, they found that, when you're in your kitchen or your bathroom and you're using electricity, or especially around water, that can be dangerous, because what if accidentally you dropped your electrical appliance into the water and then the electrical, electricity is leaking, into the water. That could electrocute you if you are also in the water, like you're in the bathtub or you have your hands in the sink. So they created these kind of outlets, which if you have a newer house or a new remodeled bathroom, they would put this kind of outlet in there. And what it does is it has a little sensor. So it checks that the current that's going out to your hairdryer and the current that's because every circuit's a loop, right? So the current leaving and the current coming back around to the other side should be the same. And if it's not, then it turns it off. It turns your hairdryer off, or it turns your curling iron off, or whatever. So this is called a ground fault interrupter, or sometimes it's called a ground fault circuit interrupter, and GFI or GFCI for short. So you can look around your kitchen or bathroom for these type of outlets. And then they've also started including them just right on like hair dryers. So here's my hair dryer, and this one has a different name because it's called ALI or something, but when it's included right on the plug, okay, but it's doing the exact same thing. It's just checking, and it will turn off the appliance if it thinks there's current leaking, to avoid electrocuting you. Now, I know that these are a hassle. Like we have one in my bathroom that doesn't seem to work right. It turns off for no reason. So that's something you could investigate. Maybe there's something wrong with the way it's wired.